What if I told you that some of the most powerful gardening techniques ever discovered aren't hiding in expensive agricultural labs or university research centers, but were perfected thousands of years ago by farmers who never heard of soil pH or nitrogen cycles? Most people don't know this, but while we've been chasing the latest fertilizers and high-tech growing systems, some of the most effective methods for growing incredible food have been sitting right under our noses, forgotten in the wisdom our great-grandparents took for granted. I've been gardening for over 3 decades, and I've spent the last 15 years tracking down these ancient techniques and testing them in my own plots. What absolutely blew my mind was discovering that these old-school methods can be very effective in home gardens. Wait until you hear about hack number 6, an old soil preparation method that can help improve crop yields while reducing water needs. And number 9 is going to completely change how you think about plant spacing. This technique from ancient farmers can significantly increase your harvest in the same square footage. If you want more of these gardening secrets that actually work in real backyards, hit that subscribe button and ring the notification bell. I share these kinds of proven techniques every week, and trust me, your garden will thank you for it. So, let's get into it. Here are 9 ancient garden hacks that can work well in modern gardens, ranked from solid to absolutely game-changing. Number 1. Companion planting with the 3 sisters, the indigenous insurance policy. Native American tribes across North America developed this corn, beans, and squash combination over 1,000 years ago, calling them the 3 sisters because they support each other like family members. The Haudenosaunee people, also known as the Iroquois, passed down detailed planting instructions through generations, treating these 3 crops as sacred gifts that were meant to grow together. This combination was cultivated by indigenous communities from Mexico to Canada. Here's why it works. 3 sisters plots can produce more total nutrition per square foot than monoculture plantings, while the beans fix nitrogen that feeds the corn, and the squash leaves create a living mulch that retains soil moisture. The corn stalks provide a natural trellis that can support bean vines, while the beans pull nitrogen from the air and convert it into a form that feeds all 3 plants. The large squash leaves shade the soil surface, reducing water evaporation and preventing weed germination. Plant corn first. Wait until it's 6 inches tall, then plant beans around the base and squash in a 4-foot radius circle. The corn provides a natural trellis, the beans add nitrogen to feed all 3 plants, and the large squash leaves shade the soil to prevent weeds and retain moisture. Space your corn hills 4 feet apart, plant 4 to 6 corn seeds per hill, and once the corn reaches 6 inches, plant 4 bean seeds around each corn stalk. Plant squash seeds in I. Circle around the entire grouping, spacing them 6 feet apart. Here's what most people miss. The timing is everything. If you plant all 3 at once, the beans will pull down the young corn stalks before they're strong enough to support the weight. I learned this the hard way in my first attempt 15 years ago, when I lost an entire planting because I was too eager to get everything in the ground at once. Think of it as a perfectly choreographed dance that's been waiting 1,000 years for you to learn the steps. Number 2. Fermented plant teas, the medieval liquid gold. European monastery gardens documented soaking comfrey, nettle, and other plants in water barrels for weeks to create liquid fertilizers. These monasteries fed communities from their gardens, and their fermented plant teas were considered valuable garden amendments. The reason these got forgotten is simple. Chemical fertilizers promised faster results and cleaner application, so these smelly but effective brews fell out of favor when synthetic nitrogen became widely available after World War II. But here's the thing. Fermented plant teas contain beneficial microorganisms and nutrients that can help plant health. The fermentation process creates compounds that plants can use, plus beneficial bacteria that can help plants absorb nutrients more efficiently. These teas also contain trace minerals that have been processed by fermentation, making them available to plants. Fill a 5-gallon bucket with fresh comfrey or nettle leaves, cover with water, let it ferment for 2 to 3 weeks until it smells terrible. Then dilute 1 to 10 with water and apply monthly. Use about 2 pounds of fresh plant material per 5 gallons of water, and make sure to cover the bucket with a loose lid to allow gases to escape while keeping rain out. The fermentation process breaks down plant cells and creates nutrients that plants can absorb through their roots and leaves. But here's the thing. The smell means it's working. Those are beneficial bacteria doing exactly what they did in medieval monastery gardens. I've been brewing these teas for 12 years now, and my neighbors always know when it's feeding time, but they can't argue with the results when they see my tomatoes in August. Think of it as a time-release vitamin that's been brewing for you to rediscover. Number 3. Moon phase planting, the ancient timing system. Farmers from ancient Egypt to colonial America planted by lunar cycles, believing the moon's gravitational pull affects soil moisture and seed germination, just like it affects ocean tides. The ancient Egyptians aligned their agricultural calendar with lunar phases, and their records show specific planting dates tied to new moons and full moons. Colonial American farmers brought these traditions from Europe, and the Old Farmer's Almanac, first published in 1792, included detailed moon phase planting calendars that farmers relied on for over 2 centuries. Here's why some believe it works. The same gravitational forces that create tides may also influence groundwater movement and soil moisture levels, with soil moisture potentially varying during certain lunar phases. The reason this got forgotten is simple. Industrial agriculture needed predictable schedules that didn't depend on celestial timing, so moon planting was dismissed as superstition when mechanized farming took over in the early 1900s. Plant leafy greens and herbs during the new moon to first quarter phase when soil moisture may be naturally higher, and plant root vegetables during the third quarter to new moon when energy moves downward into roots. For above-ground crops like lettuce, spinach, and herbs, plant from the new moon until the first quarter when the moon is waxing. For root crops like carrots, beets, and potatoes, plant from the full moon to the new moon. Here's what most people miss. The same gravitational forces that create tides may also influence groundwater movement and soil moisture levels. I started tracking this in my own garden 8 years ago, and I've noticed some patterns in my germination rates when I time my plantings with lunar phases compared to when I just plant whenever I have time on weekends. Think of it as surfing the moon's energy waves that have been pulling at your garden soil every single night. Number 4. Biochar soil amendment, the Amazonian carbon sponge. Indigenous, Amazonian peoples created terra preta, or black earth, by adding charcoal to soil over centuries, creating some of the most fertile soil on Earth that's still incredibly productive today. The indigenous peoples of the Amazon basin developed this technique by systematically burning organic matter in low oxygen conditions and mixing the resulting charcoal into their agricultural plots. These terra preta soils are found throughout parts of the Amazon basin and contain more organic carbon than surrounding rainforest soils. Modern research shows that biochar amended soils can retain more water and nutrients than regular soil, while also sequestering carbon for decades. The porous structure of biochar creates spaces where beneficial microorganisms can live and where nutrients can be stored and slowly released to plant roots. Biochar has an enormous surface area, creating significant space for nutrient and water storage. Make biochar by burning wood in a low-oxygen environment like a metal barrel with limited air holes. Then crush the resulting charcoal and mix it into compost for 2 to 3 months before adding to garden beds at a rate of 10% by volume. Drill holes around the sides of a metal barrel about 6 inches from the bottom, fill it with hardwood pieces, light a fire on top, and once the flames die down and you see mostly glowing coals, cover the barrel with a metal lid to cut off oxygen and let it cool completely. The resulting charcoal should ring like a bell when you tap it with a hammer. Here's what most people miss. Raw biochar actually steals nutrients from soil initially. It needs to be charged with compost first to become the nutrient sponge that Amazonian farmers discovered. I made this mistake in my first attempts 10 years ago and actually saw reduced plant growth until I learned to pre-charge the biochar by mixing it with aged compost for at least 2 months before applying it to my beds. This wasn't random, it was by design. Those ancient farmers understood that charcoal becomes a permanent soil improvement that feeds plants for generations. Think of it as a carbon savings account that's been earning interest for your soil. Number 5. Polyculture food forests, the permaculture pyramid. Ancient Persian and other farmers created multi-story food systems with fruit trees, berry bushes, herbs, and ground covers all growing together in self-sustaining ecosystems that produced food for centuries without external inputs. These layered food systems mimicked natural forest ecosystems, with large trees forming the canopy, smaller trees and shrubs as the understory, and herbs and vegetables growing in the filtered sunlight below. These systems were productive and sustainable, influencing garden design throughout various regions. Here's why it works. Polyculture systems can be very productive while requiring less maintenance after establishment. Each layer captures different amounts of sunlight and draws nutrients from different soil depths, maximizing the productivity of every cubic foot of space. The tree roots bring up deep minerals, the shrub layer can fix nitrogen, and the ground covers protect soil moisture and prevent erosion. The reason this got forgotten is simple. Modern agriculture focused on mechanization and monocultures that could be harvested efficiently with machines, abandoning these complex but productive systems that required hand harvesting and detailed plant knowledge. Start with dwarf fruit trees as your canopy layer. Add berry bushes like currants and gooseberries as your shrub layer. Plant perennial herbs like chives and oregano as your herbaceous layer. And finish with ground covers like strawberries and creeping thyme. Space dwarf fruit trees 12 to 15 feet apart. Plant berry bushes in the spaces between trees about 6 feet from the trunk. Establish herb patches in the remaining open areas and let ground covers fill in naturally around everything else. Choose plants that have different harvest times, so you're getting food from spring through fall. But here's the thing. Each layer captures different amounts of sunlight and draws nutrients from different soil depths, maximizing the productivity of every cubic foot of space. I started converting part of my backyard to this system 7 years ago, and now I harvest something edible from that area almost every day, from April through October, with minimal weeding or watering after the 3rd year. Think of it as a natural apartment building where every floor has been designed for you to harvest something delicious. If you're finding value in these ancient secrets, smash that like button and make sure you're subscribed, because we're just getting to the really amazing ones. The next techniques are going to completely change how you approach gardening. Number 6, Hugelkultur raised beds, the Germanic water battery. German and Austrian farmers buried logs and branches under their growing beds, creating self-watering systems that stayed productive during dry summers. The technique, called Hugelkultur or hill culture in German, was developed in regions where farmers needed to maximize water retention. This method involved building raised beds over buried wood as a way to create fertile growing areas that could survive drought years without irrigation. Modern research suggests that Hugelkultur beds can retain more moisture than traditional raised beds, while requiring less irrigation after establishment. As the buried wood decomposes, it acts like a sponge that can hold water, slowly releasing moisture to plant roots throughout the growing season. The decomposition process also generates gentle heat that can extend the growing season and creates a slow-release fertilizer system that feeds plants for years. Dig a trench 2 feet deep, layer in logs and branches with the largest pieces at the bottom. Fill gaps with smaller wood and leaves, then top with 8 inches of soil. Start with logs 6 to 12 inches in diameter at the bottom. Add progressively smaller branches and twigs. Fill all the gaps with leaves, grass clippings, or other organic matter. Then cap the whole system with quality garden soil. The finished bed should be about 3 feet tall and will settle to about 18 inches over the first year as the wood begins to decompose. But here's the thing. The magic happens in year 2 and beyond, when the decomposing wood becomes a water and nutrient storage system. In my own Hugelkultur beds that I built 6 years ago, I now water maybe once a month during our hot summers, compared to every other day for my traditional raised beds. Here's what most people miss. Use hardwoods like oak and maple, not softwoods like pine, because they decompose at the right rate and don't acidify the soil. Softwoods break down too quickly and can create anaerobic conditions, while hardwoods provide the long-term structure and slow decomposition that makes this system work. Think of it as an underground water savings account that's been collecting interest for your plants. Number 7. Mycorrhizal fungi partnerships, the ancient internet. Indigenous peoples worldwide recognized that healthy forests had networks of fungal connections between plant roots, and they transplanted forest soil to their gardens to inoculate crops with these beneficial fungi. Native American tribes would carry forest soil when they traveled, adding it to new garden plots to ensure their crops had access to the same fungal partnerships that made forest plants robust. Other indigenous peoples practiced similar techniques, moving soil from healthy native plant communities to their gardens. Modern science shows that mycorrhizal networks can significantly increase plant nutrient uptake and help plants communicate stress signals to each other. These fungal networks extend plant root systems substantially, creating nutrient pathways that can transport phosphorus, nitrogen, and carbon between different plants. When one plant is attacked by insects, it can send chemical warning signals through the fungal network to help neighboring plants prepare their defenses. The reason this got forgotten is simple. Chemical fertilizers and fungicides disrupted these natural partnerships, and most gardeners never learned that plants evolved to depend on fungal allies. The widespread use of high-phosphorus fertilizers actually causes plants to reject their fungal partners because they don't think they need them anymore. But this leaves plants vulnerable to drought and disease. Inoculate your garden by adding a handful of healthy forest soil around each transplant, or purchase Mycorrhizal inoculant and dust it on roots before planting. Avoid using fungicides and high-phosphorus fertilizers that kill these beneficial fungi. When transplanting seedlings, dip the root ball in a slurry of forest soil and water, or dust the roots with commercial mycorrhizal inoculant that contains multiple species of beneficial fungi. Maintain these partnerships by avoiding synthetic fertilizers with high phosphorus levels and never using fungicides unless absolutely necessary for disease control. Here's what most people miss. These fungi can significantly extend plant root systems and create nutrient highways between plants. I started inoculating my transplants with forest soil 12 years ago, and my plants show better drought tolerance and disease resistance compared to uninoculated plants in the same beds. Think of it as plugging your plants into nature's original internet that's been running for millions of years. Number 8. Crop rotation with nitrogen fixers. The four-field revolution. Medieval European farmers developed rotation systems that included grains, legumes, root vegetables, and fallow periods, sustaining soil fertility for centuries without external fertilizers. These rotation systems became important foundations of agricultural productivity that supported the growth of medieval communities. Proper rotation systems were effective at increasing agricultural productivity compared to earlier systems, allowing the same amount of land to support larger populations. Research shows that proper crop rotation with legumes can maintain soil nitrogen levels while reducing pest and disease pressure compared to continuous cropping. The nitrogen-fixing bacteria in legume root nodules can add significant nitrogen to the soil. Different plant families also have different pest and disease vulnerabilities, so rotation breaks these cycles naturally while maintaining soil biology and structure. The reason this got forgotten is simple. Chemical fertilizers made it seem unnecessary to maintain soil biology, but we're learning that healthy soil ecosystems are important. When synthetic nitrogen became cheap and widely available after World War II, farmers abandoned rotation systems in favor of continuous cropping with chemical inputs, not realizing they were disrupting soil biology that had taken time to develop. Divide your garden into 4 sections and rotate annually. Year 1, leafy greens and brassicas. Year 2, legumes like beans and peas. Year 3, root vegetables like carrots and potatoes. Year 4, cover crops or fallow with compost addition. Plan your garden layout so you can easily move each crop family to the next section each year, keeping detailed records of what was planted where so you can maintain the rotation schedule. The legume year is crucial because beans and peas actually add nitrogen to the soil for the following year's heavy-feeding crops. Here's why it works. Different plant families have different nutrient needs and pest vulnerabilities, so rotation breaks disease cycles, while legumes actually add nitrogen to the soil for the following year's crops. I've been following a strict 4-year rotation in my main vegetable garden for 18 years now, and my soil tests show that nitrogen levels have remained good over time, despite never adding synthetic fertilizers. Think of it as a 4-year dance that's been choreographed to keep your soil healthy and productive. Number 9, intensive square foot spacing, the ancient productivity method. Ancient farmers developed intensive planting systems that grew crops in precise patterns, maximizing every inch of their limited arable land to feed their communities. Various cultures created garden systems with spacing arrangements that could produce significant amounts of food in limited terrain where arable land was scarce. These intensive systems were productive, supporting large populations despite having limited arable land per person. This wasn't random, it was by design. These farmers understood that intensive spacing mimics how plants grow in nature, close together in communities, not isolated in rows. They observed that wild plants naturally grow in dense communities where they protect each other from wind, share root zone moisture, and create beneficial microclimates that help all plants thrive. Modern intensive gardening methods, based on these principles, show that dense spacing can produce significant yields in small spaces while using less water. The dense planting creates a living mulch effect, where plant leaves shade the soil surface, reducing water evaporation and preventing weed germination. Plants also create beneficial microclimates for each other, with taller plants providing wind protection and soil shading for smaller neighbors. Instead of planting in rows, divide beds into 12-inch squares and plant each square according to plant size. 16 carrots per square, 9 beets, 4 lettuce, or 1 tomato. This eliminates wasted space between rows and creates a living mulch effect. Use a permanent grid system made from wood strips or string to divide your beds into 1-foot squares, then plant each square based on the mature size of the plants. Small plants like radishes get 16 per square, medium plants like lettuce get 4 per square, and large plants like tomatoes get 1 per square. Here's what most people miss. The plants actually protect each other when spaced this intensively, creating beneficial microclimates and reducing water evaporation. When I first tried this system 20 years ago, I was worried about overcrowding. But I discovered that plants actually grow better in these dense communities than they do in traditional, widely spaced rows. But here's the thing. This only works with excellent soil, because you're asking more plants to thrive in less space, so soil fertility becomes absolutely critical. You need soil that's rich in organic matter and has excellent drainage, because you're supporting more plants in the same area. I spend extra time building my soil with compost and organic matter in my square-foot beds. But the increased productivity more than justifies the extra soil preparation. Here's what absolutely amazes me after 3 decades of gardening. Every single one of these techniques works because ancient farmers understood something we're just rediscovering, that gardens are living ecosystems, not production factories. They worked with natural processes instead of fighting against them. The indigenous farmers who developed Three Sisters planting understood plant partnerships. The medieval monks who brewed plant teas understood soil biology. The German farmers who buried logs understood water cycles. The farmers who developed intensive spacing understood plant communities. They didn't have scientific explanations for why these techniques worked, but they had something even more valuable: generations of careful observation and testing in real growing conditions. What I find most exciting is that modern research keeps validating these traditional approaches. We're rediscovering that our ancestors weren't primitive, they were sophisticated observers of natural systems. If this video helped you see your garden in a new way, smash that like button to help other gardeners discover these secrets. Drop a comment below and tell me which ancient hack surprised you the most. Are you Team Three Sisters companion planting, Team Hugelkultur water batteries, or Team Square-foot intensive spacing? I read every comment, and I love hearing about your own experiments with these traditional techniques. Make sure to subscribe and hit that notification bell, because I'm always testing these old-school techniques and sharing what actually works in real gardens. Next week, I'm sharing more traditional preservation methods that can help you store your harvest for months without refrigeration, using techniques that sustained our ancestors through long winters. Remember, sometimes the most powerful gardening wisdom isn't in the latest agricultural journal or expensive garden center product. Sometimes it's in the knowledge our ancestors developed over centuries, just waiting for you to rediscover it. These techniques have been tested not just in research plots, but in real gardens feeding real families for hundreds or even thousands of years. That's the kind of proven track record you can trust with your own garden.